Let's take a look at GeoGebra to see how we can use it to help us with learning about theorems related to tangents. To begin, let's turn off our axes and create a circle. Next, let's get a tangent line through point B. To do this, go over here to Tangents, select point B, and then the circle. Let's put a point on this tangent line. And let's also draw the radius, or the segment, from A to B. What appears to be the measure of angle ABC? What appears to be the relationship between the radius and the tangent line? Let's measure this angle to find out. It appears that angle B here is a right angle, no matter the size of the circle. So the radius is always perpendicular to the tangent at the point of tangency. Let's look at one other theorem related to tangents, or a corollary related to tangents actually. Let's get a circle again. And let's this time put a point outside the circle and draw a tangent line from point C to the circle. Then let's get a point of intersection. So let's actually get those points of tangency. What appears to be true about segments CD and CE? Let's measure the length of those segments to find out. It appears that they're congruent. But why does that make sense? Let's think about that. Well, if we draw in the radius, we know the radius is perpendicular to the tangent, and let's draw in segment CA. Here, triangle CDA is a right triangle and CEA is a right triangle. We also know that EA and DA are congruent to each other because their radii have the same circle, and CA is congruent to itself. So why would these two triangles be congruent to each other? Did you say hypotenuse leg? Well, that's good, because then if those triangles are congruent to each other, CE and CD would be congruent to each other because they're corresponding parts of congruent triangles.